Jam physics students, let me quickly teach you about semiconductors. Now, what are semiconductors? They are simply materials that have their conductivity lying in between what a pure conductor can do and what an insulator can do. So, in other words, you can call them semi-insulators or literally semiconductors. Now, you see these semiconductors, we have two current carriers in them. We have the free electrons and we have the holes. Now, quickly, let me talk about solids. One thing about solids is that there is these two bands that we know in solids. We have the conduction band and we have the valence band. The conduction band and the valence band, in between them, we have a gap known as the forbidden gap or the band gap. Now, for conductors, this space is nothing. There is no space between the conduction band and the valence band, which means that the two of them, they coincide. But in insulators, the band gap is so wide, very wide, making the conduction band and the valence band far apart. But in semiconductors, we just have this space very moderate, or let me say very demure, so it's not so wide like that. And that is, you can differentiate between conductors and all of these guys like that. Now, quickly, the effect of temperature of by the way, semiconductors are those group 4 elements like silicon and germanium. Now, there's something that temperature does to semiconductors. For conductors, when you increase temperature, resistance increases, thereby reducing their conductivity. But don't forget about the band that I talked about the other time. We have the conduction band and we have the valence band. The electrons in the valence band for semiconductors, when you increase temperature, they are able to excite and move to the conduction band. And this actually has a positive effect, reducing their resistance and causes their conductivity to increase. So conductors, temperature increases resistance and reduces conductivity. But for semiconductors, temperature reduces resistance and increases conductivity. Now, quickly, let me talk about doping. Doping is the process of adding impurities to semiconductors. Now, what do I mean by adding impurities? You can dope with two different types of elements. We have the trivalent element and we have the pentavalent element. Trivalent element, of course, 3 elements in their valence shell, and then pentavalent element, we have they have 5 elements in their valence shell. If you dope with trivalent elements, you dope a semiconductor with trivalent element, what it produces is what we know as p-type semiconductors. Don't forget the free electrons and holes that I talked about the other time. P-type semiconductor, they have more holes than free electrons. That's what makes them p-type. Now, if you dope on the other end with a pentavalent element, doping with a pentavalent element gives you what we call an n-type semiconductor. And for these guys, they have more free electrons than holes, and that is the difference between the two of them. Now, the p-type semiconductor and the n-type semiconductor, what if we amalgamate them together? When we bring both of them together, what we're actually creating is a junction, is a p-n junction. Now, in this p-n junction, there is a space, something like a space in between them, and this space is known as the depletion region. And that takes me to my next point. If I bring an external source of voltage and I connect it to this p-n junction, and there are two ways to do this connection. If, of course, is external source of voltage is like a cell which has the positive terminal and negative terminal. If I connect the positive terminal at this end and the negative terminal of the cell is like this. Now, if on the other end, the the p-n junction, the p-type is on this side, such that the p part is connected to the positive terminal and the n part is connected to the negative terminal, then what I have there is the forward bias. And what happens here is that the depletion region closes up. And when that happens, resistance decreases and we have more flow of current. Now, if I reverse the terminal of this battery, that is placing the negative terminal here, placing the positive terminal here, so that the negative terminal is connected to the P side and the positive terminal is connected to the N side, what we have there is reverse bias. And in this case, resistance increases and then there is no much flow of current like that. So learn that the forward bias and the reverse bias. Now, this PN junction can be used as rectifiers. Now, what are rectifiers? Rectifiers are just those materials that allow, we can convert, let's say, AC to DC using rectifiers. It allows flow of current in one direction. Now, let me quickly talk about transistors. Now, transistors are just like, we have combination of different semiconductors as well. Now, we have two types that I will majorly talk about here. We have the PNP transistors, and we have the NPN transistors. Now, for the PNP, is such that the P part serves as the emitter and the collector, and the N part serves as the base. For the NPN, the both N parts serves as the emitter and the collector, and then the P part serves as the base. One of the usefulness of transistors is that transistors can be used as switches or amplifiers. That is what you use transistors for. And that's basically almost everything you need to know about semiconductors. If you want to know more, or you want to ask any question about semiconductor or any physics question at all, drop a comment below and I'm going to respond to you. Till that time, I'll see you. Bye.